Hi students, let's have a look at this equation. X cube minus 12x square plus 44x minus 48 is equal to 0. And the instruction is find all three roots of the above equation if one of the roots is equal to the sum of the other two. And we are told that all roots are real. So let's begin. So let us say let A, B, and C. I'm sorry, I'll just make that correction. Let A, B, and C be the three roots of the equation. Okay. Now, we are told that one of the roots, let's say A, is equal to the sum of the other two roots. So this is also given. Okay. Now, according to Vieta's formula, if px cubed plus qx squared plus rx plus is equal to 0, and A, B, and C are its roots, then the sum of the roots A plus B plus C is given by minus Q slash P. That is minus Q divided by P, where Q is the coefficient of the quadratic term and P is the coefficient of the cubic term. And the sum of the subproducts of the roots is given by R by P, where R is the coefficient of the linear term and P is the coefficient of the cubic term. And the sum of the subproducts is AB plus BC plus CA, where A, B, and C are the roots of the equation. And also the product of the roots is given by minus S divided by P, where S is the constant term and P is the coefficient of the cubic term. So we see that this formula, Vieta's formula, gives the relationship between the roots of an equation and its coefficients. The Vieta's formula gives the relationship between the roots of the equation and the coefficients. Okay, now using this, first thing we will do is add up all the roots, A plus B plus C, and this is equal to minus Q by P. So in this case, this is going to be equal to minus of minus 12, where Q is the coefficient of the quadratic term divided by P, which is 1. Okay. The coefficient of the cubic term is 1. It's not mentioned. So we are going to have A plus B plus C is equal to 12. Next, we will have the sum of the subproducts. That is, okay, I'll just make a change. I made a small mistake here. Sum of the subproducts is AB. Oh my God. Plus BC plus CA is equal to R by P. That is the coefficient of the linear term, in this case 44, by P, which is 1. And lastly, the product of the roots. A, B, C is going to be equal to minus S by P. In this case, it's going to be minus of minus 48, which is equal to 48. Rather, minus 48 by 1, which gives you, minus of minus 48 by 1, which gives you 48. Okay, now that we have all these three results, let us see what we can do further. Now, since we know that A is equal to B plus C, this equation A plus B plus B plus C equal to 12 can be rewritten as A plus this B plus C is equal to A. So this is also A. So we have 2A is equal to 12. A is equal to 12 by 2. So A is equal to 6. We have 6. Okay, is there anything else we can do? Now let's go to the second equation here. Look at this one. The sum of the subproducts AB plus BC plus CA is equal to 44. Now, here I can combine AB and CA and write it as A into B plus C plus BC is equal to 44. Okay, I hope that's clear. I'll rewrite it. A into B plus C. That is, this gives me AB plus CA, and then I have BC remaining, and that's equal to 44 by Vieta's formula. Now, we already know that B plus C is equal to A, where here B plus C is equal to A. Therefore, I can say A into B plus C is A into A plus BC is equal to 44. That is A square plus BC is equal to 44. We know that A is 6. So since we know that A is 6, it's here. 36 plus BC is equal to 44. So that means BC is going to be 44 minus 36. Uh, that would be 8, isn't it? Yeah. So BC is equal to 8 and A equal to B plus C equal to 6 because A is also equal to B plus C. So at the end, we have the following results. We know that B plus C is equal to 6, and we also know that BC is equal to 8. Okay, hope that's clear. I can kind of make it clearer. These are the two results we have. Okay, these two results connect the two roots of the equation, this equation. The sum of the roots is 6, and the product of the same two roots is 8. Now, we can also regard B and C as just any two numbers, okay, just any two numbers. And if the sum of the two numbers is 6 and the product of those two numbers is 8, then we can assume that these two numbers B and C are the roots of a quadratic equation, which we can construct as t square minus B plus C t plus BC. That is, if B and C are the roots of a quadratic equation, and this equation is different from the cubic equation, okay? We assumed B, C, and A to be the roots of a cubic equation, and then we did some manipulation using Vieta's formulas, and then we came to the conclusion that B plus C is equal to 6 and BC is equal to 8. But now, since we have sum of two numbers and also the product of those two numbers, we can imagine or assume that these two numbers form the roots of a quadratic equation, and I can construct the quadratic equation like this. And I do it like this based on certain well-known rules which define the relationship between the roots of a quadratic equation and its coefficients. Okay? So I can now rewrite this quadratic equation as minus 6t plus 8 equal to 0. Okay. Now, once I do this, I can solve for the value of t. I just need two numbers that will add up to be the coefficient of the linear term, and the same two numbers multiplying to be the product, multiplying to be the product, which will be the constant term. So those two numbers in this case are basically minus 4 and minus 2. So obvious. So basically t square minus 2t minus 4t. I'm expanding the linear term, plus 8 is equal to 0. Now I can factorize this. So this is going to be, yeah, I can factorize this as t minus 2 and t minus 4. Okay, factorization of quadratic equations. There are videos about that online. I have uploaded them. You can verify those videos of mine to know how to solve quadratic equations using the factorization method. Okay, what does this mean? This means that t is equal to 2 and t is equal to 4. Any one of the results. T is equal to 2 and t is equal to 4. Hope it's clear now. Okay. And what exactly are these two values of t? They are the roots of the equation. And we already assumed the roots of the equation to be b and c. And on that basis, we constructed this quadratic equation. So we can say b is equal to 2 and c is equal to 4. Or vice versa, other way around. We can in fact write it like this. So if this is the case, then A should be equal to B plus C, that is 4 plus 2, which is 6. And this we already independently deduced. See this here, we deduced this independently. So now we have the three roots of the equation, 2, 4, and 6. And you will note that one of the roots is equal to the sum of the other two. If you enjoyed how I went about solving it, you can, I will give you more problems now. I'll solve more problems. Type, you can go through them and try them.